What's up, mathematicians? Justin here, and in this video we'll be talking about right triangle trigonometry. So before we get started, let's address the question of why do we even use trigonometry? What is it useful for? So first of all, trigonometry can be used to measure things that cannot be measured directly. Of course, we saw an example of this with the tree that we measured, something that was too tall or we didn't have the equipment to measure directly. A second thing that trigonometry is also useful for is in planning out physical structures. So for example, if you are an architect or a carpenter or an engineer and you want to have a certain set of dimensions to a structure that you are designing. First of all, you can use trigonometry to determine if that set of dimensions is even possible. And then you can also sort of set the dimensions that you want to control and use trigonometry to figure out what the other dimensions will be, the ones that you haven't set. So what do you need in order to use trigonometry, to apply trigonometry to a situation? Well, first of all, for the trigonometry we're talking about right now, which is right triangle trigonometry, we start with a right triangle. Once we have a right triangle, we need two more pieces of information. At least one of those must be a side length. So given a right triangle, you can do trigonometry on that right triangle if you have two side lengths or if you have one side length and one angle. Finally, before we get started with our investigation, I guess this video of looking at how to apply the concepts of trigonometry, let's remind ourselves of the three trig ratios. These are sine, cosine, and tangent. The sine of an angle is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. Okay, now we'll look at a few examples where we'll apply these concepts of trigonometry to some right triangles. So here's the first example. Of course, I encourage you to take notes as well in your own notebook. So the first example, we're going to be looking at a triangle, and I'm going to go ahead and get my straight edge out here so I can draw nice straight lines, just because that makes me happy. All right, so here, and then I'll draw it up to there. Draw that line, and then draw in my altitude. Here is the right angle in this triangle. I'm going to go ahead and, well, as I mentioned earlier, you need two pieces of information in order to be able to apply trigonometry. So the two pieces of information I'm going to determine in this particular problem are this angle right here. I'm going to say this angle is 38 degrees. Now keep in mind that this triangle is not necessarily drawn to scale, so I'm not going to guarantee that this is actually a 38-degree angle. And then I'm going to say this bottom length of the triangle is length 17. 17 units. I'm not going to worry about specifying the type of unit at this point. And then I'm going to say, well, the thing that I want to know is this, the longest side, also known as the hypotenuse. So I like to also write out, as a reminder, the different ratios here on the paper so I have them in front of me. So I know that the sine is equal to opposite over hypotenuse. I know the cosine is equal to adjacent over hypotenuse, and I know that the tangent is equal to the opposite over the adjacent. Okay, so now that I have these two pieces of information plus my unknown, the thing that I want to find out, one thing I recommend that you do is write out the opposite, the adjacent, and the hypotenuse for any triangle you're applying trigonometry to, at least for now. When you get better at it, you won't need to do this, but for now, I recommend it. It's going to help you stay on track and make sure you use the correct trig ratio to solve the problem. And so let's see, so we'll start with opposite, and here's the angle. So what is the length of the side opposite this angle? Well, that's this side here. And I don't know, actually. It's not given to me, and it's also not the thing I'm trying to find. So I'll just leave it blank. The adjacent, then, I'll turn to next. And from the perspective of this angle, the side adjacent to it, well, there are two sides touching it, right? This side and this side. But the longest side, the side across from the right angle, is always the hypotenuse. The adjacent side is the side touching the angle that's not the hypotenuse. So that's this side down here, 17. So the adjacent is, the length of the adjacent is 17. And the length of the hypotenuse is x. It's my unknown, the thing that I want to find in order to solve this problem. Okay, now I see that the lengths I either know or am interested in are the adjacent and the hypotenuse. So I'm going to look at my ratios and I'm going to decide which one to use for this situation. Well, which of these ratios has adjacent and hypotenuse? I don't care about the opposite. Well, we see sine has opposite, tangent has opposite. Cosine is the one with just adjacent and hypotenuse. Okay, so that means I'm going to use the cosine ratio in order to solve this problem. So let's go ahead and write this out. The cosine of the angle, now because I know the angle, I'm not going to put theta in here, I'm just going to go ahead and write 38 degrees, is equal to the length of the adjacent, which is 17, divided by the length of the hypotenuse, which is x. Okay, now all I need to do is a little bit of algebra to find out what x is. So I'll multiply both sides by x here, and those cancel out, and so I get x times cosine of 38 degrees is equal to 17. Now, in order to get x by itself, I'll just divide both sides by the cosine of 38 degrees. Divide by the cosine of 38 degrees. These will cancel out. So x is going to equal 17 divided by the cosine of 38 degrees. Okay, but what is the cosine of 38 degrees? Well, remember that these things have already been, computed. So you can just plug them in a calculator or look them up on a table. I could go right here to my table and let's see. Here's 38 degrees and the cosine is this second column. So I'll look up what I have here. 38 degrees, the cosine is 0.788 or 0.79 if I round to the nearest hundredth. Well, I'm still going to need to plug in my calculator here because I can't do that in my head. So what was it again? 17 divided by the cosine of 38 degrees, so divided by 0.788, and I'm going to get 21.57. I'll round to the nearest tenth, say 21.6. But remember, these ratios that we see on this paper are also stored in your calculator if you have a calculator with sine, cosine, and tangent on it. So we could just as easily say 17 divided by the cosine of 38 degrees. Make sure your calculator is in degree mode in order to do this computation though. And you'll see once again we get 21.57, round to 21.6. And actually let me just show you, because one issue that I see students run into a lot when they plug this in the calculator is they get an answer that's just totally off and they're like, why? What's wrong? I thought I did the calculation correctly. And oftentimes the issue is that their calculator is in the wrong mode. So your calculator is probably not the same as the one I have. So you may have to do some research online to figure out how to do this. But basically, or you could probably figure it out on your own maybe, you have to go to the mode. So for me it's second, more, and then you see right here the options radian and degree. So in order to do these problems with degrees, which is what we're going to use in this class, you'll use radians in future math classes, but we're going to make sure that the calculator is in degree mode. So highlight that, hit enter, and then you can go back to the main screen and then you'll be able to calculate these things properly. So now I know the value of x in this problem. X is equal to 21.6. And I'll just put a nice little box around that. So that's my first problem. Let's do another example as well. So let's see. Example number 2. Let's start by drawing out a triangle, as we did in the last one. So we'll pick 3 points like this, similar to before, and draw in my sides. Of course, you don't necessarily need to use a straight edge to do this, but I just like the way it looks. I have nice straight sides. Okay. And here, of course, is my right angle. Now for this one, I'm going to, instead of determining one side and one angle, I'm going to give two sides. So you may recall earlier in the video I said you need two pieces of information beyond the fact that it's a right triangle. At least one has to be a side. So we can have one side and one angle, or we can have two sides. Let's try the approach where we have two sides given. So I'll say the side here on the bottom of the triangle is length 76. And this side right here is going to be length 29. And the unknown is my angle. That's the thing that I want to find out. Now, as we did in the previous problem right here, once again, I'm going to suggest that you actually write out the lengths and assign, write out the opposite, adjacent, and hypotenuse. So, all right, opposite, adjacent, hypotenuse. So what is the opposite in this triangle? Well, here's our angle, and the side opposite the angle is over here. The length of that side is 29. What is the length of the adjacent side? Well, remember, it's the side that's touching the angle, that's not the hypotenuse. So it is 76. And what's the length of the hypotenuse? It's not given. It's not something I'm interested in finding. I don't see a variable there that I'm trying to solve for. So I don't care about it. I'm just going to go ahead and cross it out. So I want to find the ratio that involves the opposite and the adjacent, but not the hypotenuse. So I can go up here and look, and I see, okay, tangent is equal to the opposite over the adjacent and doesn't include the hypotenuse. So I'm going to want to use the tangent ratio. So let's go ahead and write that here. So the tangent is equal, oops, let me add theta there. So I don't know the measure of the angle. I'm going to put theta as a variable, as a placeholder, until I find the measure of the angle. Okay, so let's see. It's equal to the opposite over the adjacent. So the tangent of theta is equal to 29 divided by 76. Okay, well, let's go ahead and figure out what do we get when we take 29 divided by 76. 29 divided by 76. That's 0.38 if I round to the nearest hundredth. Okay, so 0.38. Okay, now this is an easy spot to get stuck because it's like, okay, I know the ratio, but how does that tell me the angle? Well, if we go back to our table, we can look for this ratio of 0.38 in the tangent column. So let's go to the tangent column here. And scrolling down, scrolling down, scrolling down. Okay, here I see a 0.36. And here I see a 0.38. It's just a little bit bigger than this, right? 0.384 versus 0.381 or 382 if I round. But it's definitely closer than the one after it, the 0.40 and the 0.36. So this is the closest one to the ratio that I have. So I can say, okay, what angle measure corresponds with that tangent ratio? And we see right here the angle measure is 21. So that would indicate to us that theta is equal to 21 degrees. Okay. But what if you don't have the table or you'd just rather use your calculator? Well, this is where we have to use the inverse trig functions. So basically, instead of putting in an angle and getting out a ratio, we need to put in a ratio and get out an angle. If I put in the tangent of, what was the ratio, 0.38, it's going to give me this because it's thinking that I'm asking it for the tangent of 0.38 degrees. But I want this to be the ratio. So you'll see above the sine, cosine, and tangent, sine -1, cosine -1, tangent -1. Those are the inverses. They're also known as arc sine, arc cosine, and arc tangent, which I know is a little bit confusing, but just be aware of that. So in the calculator, instead of finding the tangent of 0.38, I'm going to go ahead and find the inverse tangent, or tangent to the -1 of 0.38. Hit enter, and you see 20.8. If I round that to the nearest degree, it is in fact 21 degrees. So I can use the calculator as well as my table to calculate that degree measure. So that's the final answer. Okay, so those were a couple examples of how you can use the techniques of trigonometry to solve for unknowns, sides or angles, within right triangles. In the next video, we're going to be looking at some applications, some more real-world, hands-on type applications where these ratios come in really useful. Hope to see you there.